Decibel arithmetic. Now that we've defined the unit of sound pressure level, or the decibel, and we know that it's a logarithmic ratio, we have to have a method of adding together different sound levels, or if you have two different sound sources, what's the overall sound level that results? But because it's a logarithmic ratio, you cannot use arithmetic addition to add up sound pressure levels. So this could be quite difficult if you don't have a computer or a calculator. There is a shortcut method to doing logarithmic addition quickly. So let's go through what logarithmic addition means. So let's take the example of two sound sources that are each 45 decibels. If we use arithmetic addition, it would add up to 90 decibels, but this is incorrect. This is not the resulting sound pressure level because the decibel is a logarithmic unit. So what we theoretically have to do is, with a 45 decibel sound pressure level, we then have to go back to what the original pressure squared was to then add pressures squared together arithmetically to get the overall pressure squared. Sounds unwieldy, sounds like a lot of work. So if we do the reverse engineering of the calculation, you can see here to get to 45 decibels for one source of sound, it would be a pressure of 0.0035 divided by that reference sound pressure I talked about earlier, which is 20 micropascals. You would then square it, then do 10 log of that calculation, and it would be 45 dB. So for two sound sources, each of 45 decibels, you would have two sound pressures of 0.0035 squared, added together, divided by that 20 micropascal squared, and the result is actually 48 decibels. So if you had multiple sound sources, you would then use this equation here to calculate the overall sound pressure level when you know each sound pressure level in decibels. So the total sound pressure level of multiple sources would be 10 log 10 to the power of L1, which is the first sound pressure level, divided by 10, plus 10 to the power of L2 over 10, plus 10 to the power of L3 over 10, etc. So it's a very long-winded way of calculating sound pressure level, which is easy to do with a spreadsheet or with a calculator. But when you don't have a calculator or a phone in front of you to do the logarithmic addition of different sound pressure levels, we have a shortcut method which is really convenient. So if you have two sound pressure levels that are 0 or 1 decibel apart, then you'd add 3 dB to get the overall sound pressure level. So going back to that first example, a 45 dB source plus a 45 dB source equals 48. Similarly, if you had a 45 decibel source plus a 46 decibel source, you'd still add 3 dB, which would equal 49 dB. Now, if the difference is 2 or 3 between the two sound sources, you just add 2 dB. So for a 68 dB source plus a 70 dB source, the overall sound pressure level is 72 dB. If the difference is 4 to 9, you just add 1 to the highest sound pressure level. So 21 dB plus 13 dB equals 22 dB. Now, if the difference between two sound power levels is 10 or greater, then that lower sound pressure level doesn't contribute at all to the overall sound pressure level that is heard. So if you have a 59 dB source plus a 70 dB source, the overall sound pressure level is still 70 dB. Now, the same principle applies for when you have octave band sound pressure levels, or a noise spectrum is what we call a series of sound pressure levels in different octave bands or third octave bands. It's a spectrum of sound. So theoretically, you have these octave band sound pressure levels. All you do is you do the logarithmic addition in the neighboring octave bands to get the overall level. So in this case here, 63 dB plus 52 dB, that's more than 10 decibels difference. Therefore, the overall sound pressure level is still 63 dB. In the neighboring band, a 45 dB source plus a 39 dB source, that has a difference of 6 dB. So when you have a difference of 6 dB between the two sound levels, you add 1 to the higher level. Therefore, the overall level is 46. You do that for each of the octave bands until you have the logarithmic additions for each of the octave bands. Then you add them together again. So in this case, we have a 63 dB overall sound level plus a 46 dB overall sound level. That is more than 10 dB difference. Therefore, the resulting sound level is 63 dB. You do the same for the resulting additions here, where we have 37 dB plus 32 dB, which is a 5 difference. When you have 5 difference between sound pressure levels, you add 1 dB to the highest sound pressure level. So that is 38 dB. And finally, to get the overall sound pressure level from the octave bands, you add that 63 dB to the 38 dB. And in this case, that's more than 10 difference. So the overall sound pressure level is 63 dB.